Hello everyone. Today we're going to look at complex numbers. So complex numbers is basically an easy subject. If you know the basics of mathematics, you won't struggle with complex numbers. Because in complex numbers, it's just one new idea that will be introduced. To say now, a square root of -1 is equals to j. So remember, previously a square root of -1, when you put it inside the calculator, it actually gives you undefined. But now we are defining the square root of -1 to say now the square root of -1 is equal to j. So now let's say, for example, they say you must evaluate the value of square root of -25. So remember, when you put the square root of -25 inside the calculator, it will give you undefined. But now we have said what? The square root of -1 is equals to j. So basically we can expand to say now we have 25 multiplied by -1. So the answer here, it will be what? It will be a square root of 25 multiplied by square root of -1. So you can actually expand it like this. Okay, so now let me talk about an important issue here. So every time when you introduce a square root, so basically the answer that you'll get, it will either be positive or negative. This is very much important. So if you introduce a square root anywhere, the answer that will come out, it will be positive or negative. But we know now the square root of -1 is equals to j. Okay, so now the square root of 25, it will be how much? It will be plus or minus 5. And then the square root of -1, it will just be j. Okay, so that's how you actually find the square root of -25. So now let's say you are given a problem which is solve for x, but then this solve for x actually is a solve for x that has a complex number. So for example, you have x squared plus 1 being equals to 0. So what you will find out is that x squared is equals to -1. So remember, for you to get the value of x, you have to introduce the square root. And remember, every time when you introduce the square root, the answer will be plus or minus. So the answer here will simply be plus or minus what? J, because we now know the square root of -1 is equals to j. It's no longer undefined. I hope you get the idea that the square root of -1 is not undefined when you are dealing with complex numbers. Okay, so the second thing that you must learn is that in complex numbers, you actually have the real numbers, okay, or the real part of the complex numbers, and you also have imaginary part of complex numbers. Let's say, for example, you have, let's say x is equals to, let's say 2 plus j3. Okay, so now the part that does not have a j is actually a real part of the complex number. And then the part that has j is an imaginary part of the complex number. Because remember, in your calculator, you can actually get the real numbers or the real part of your complex number. For example, when you put a square root of a number that is negative, it will actually be undefined. But the number doesn't mean it does not exist. It exists, but as an imaginary number. So the part that does not have j is a real number, is a real part of a complex number, and then the one that has a j is an imaginary part of the complex number. Okay, and then next we need to learn how to add and subtract complex numbers. So let's say, for example, we have a complex number that consists of both real part and imaginary part. Let's say it's 3 here, and then it's added with another complex number, which is, let's say, 4 plus j7. Okay, so normally what you're gonna do, you're just gonna treat this as any numbers like terms. When you have like terms, that means real part of these complex numbers are like terms, and imaginary parts will be like terms. That means you will add real parts with real parts and imaginary parts with imaginary parts. So this equation actually simplified to say now we have 2 plus 4, because these are the real numbers or the real part of the complex number, and then for the imaginary part we have j3 plus j7. So you just add the real part, it's going to be 6, then you also add the imaginary part, which is what? Which is j10. Okay, so basically here I'm writing it as j10. It's not a difference. You can also write it as what? As 10j. So it's just it's I don't know, they actually write it like this when they write a complex number. They write j first and then the number comes after, but it's still the same as 10j, because now here in complex numbers we know now we are dealing with what? With j as a square root of -1, not actually j as a direction when we were dealing with vectors, but we know j is what? Is a square root of -1. So now here we have to learn, if ever we do what, we square, we cube, we give a j an exponent, what will happen to j? Let's say, for example, firstly, when you have j that has an exponent of 1, we basically know now j is equals to the square root of -1. And then now when we have j has an exponent of 2, we'll basically say, okay, j is what? J is square root of -1, and then we also multiply by square root of -1 because it's j squared. That means the answer that you add is what? Remember, when you multiply this square root of numbers that are the same, you will actually have what? The square root will cancel out. So the answer that you will have here, it will actually be -1. Okay, I hope that makes sense. Let's say, for example, you have a square root of a multiplied by square root of a. So automatically we will know now the answer is what? Is a. Because when you have two square roots that are multiplying, the square roots will cancel out and they will leave that number inside the square root. But the number inside the square root has to be the same. It's the same thing as if you have the square root of a all squared. So basically this squared will cancel the square root. So the answer will only be a. So it's the same thing here on this one. So it's square root of -1 multiplied by square root of -1. So square root of -1 multiplied by square root of -1 is actually -1. So the square root cancel out, and then you keep the number same inside the bracket as -1. Okay. Now let's say we have a j as cubed. So we'll have square root of -1 multiplied by a square root of -1 multiplied by a square root of -1. So what will happen is that when we multiply these two, square root of -1, we know our answer will be -1. And then now here when we multiply the square root of -1, we know the square root of -1 has a value j. So the answer will simply be -j. Okay. So now when you have j to the power 4, let's say for example you have now j to the power 4 Sorry about that. So j to the power 4, it will be equals to what? To the square root of -1 multiplied by square root of -1 multiplied by square root of -1 multiplied by square root of -1. So the answer will be how much? You know, if a square root of -1 multiplied by square root of -1, it will give us -1. Then also a square root of -1 by square root of -1, it will give us -1. So we now know the square root of j to the power 4 is equals to +1. I'm only going to show you up until to the fourth exponent. So basically these ones, I think you need to know them by heart so that you can apply them. If ever you have a j to the power of 10, you can divide it into numbers that has 4 and 2 or something like that, so that it can be easy for you to simplify it. So let me just make it, okay, let me just write them here at the top to say now square root j is equals to what? Square root of -1, and then j squared is equals to -1. We have proved that. And then j cubed is equals to -j. And then now j to the power 4 is equals to 1. Okay, so now let me erase here. And let's just make a typical example. To say now, they say you must find the value of, let's say, j to the power of 17. Okay, so basically, if you know now the j squared is actually -1, j cubed is -j, and then j to the power 4 is 1. So you can say, okay, I can write this one as what? As j to the power 4, and j to the power 4, remember when you multiply the same base, you add the exponent, so that means it will be 8. And then now you say j to the power 4, so that means it will be how much? It will be 12. And then you also say again j to the power 4, that means it will be how much? It will be 16. And then you will say just j to the power of 1. So basically at the end you know that your answer will be j, because of what? J to the power of 4 is only 1. So 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by j will lead us to j. So basically this ones here, 1 up until 4, it will actually help you to simplify your problems very quickly. Okay, so the next part is multiplications of complex numbers. Let's say, for example, we have a complex number that consists of a real number, a real part, and imaginary part. Let's say it's 3 here, and then let's say here we have 3 plus, let's say, j5. So we will normally do the very same thing that we do as we solve binomial multiplications. You use FOIL method, or you use whatever that you use. So you just multiply out. So the first term will multiply with both the terms in this bracket, and then the last term will also multiply with both the terms in the bracket. So basically, you're going to say this one multiply by this, and this one multiply by that. And then the next thing you will do, you say this one multiply by that, and this one multiply by that. So the answer will be how much? So it's going to be 2 multiplied by 3, which is going to be 6, and then 2 multiplied by j5, which is going to be how much? It will be j10. And then now you will say j3 multiplied by 3, it will be how much? It will be j9. And then now here, j3 multiplied by j5, that means it will be j squared, what? 50. Okay, so if ever you have j and j, you can add them. And then now remember, what is the value of j squared? So remember, j squared, you just have to know it by heart to say now j squared is equal to 1. So the answer that you will have here, it will be how much? Let me just make a line here. You will have 6, 10 plus 9 is going to be what? It is going to be j19. But now here, because we have j squared, we know j squared is equals to how much? Is equals to negative 1. So basically we will have what? Minus 15. So the minus 15, you can add it with, now it's now becoming a real part, so that means you can add them here with the other real part. So it's going to be 6 minus 15, which is going to be how much? Which is going to be negative 9 plus j19. Okay, so you see on the previous part of exponents, it will actually help us to save time when we are solving. Just imagine when you get here to j squared, you will have to say, oh, what is j squared? Now you will have to say square root of negative 1 multiplied by square root of negative 1, and you will have to realize at the end, oh, the answer is negative 1. But if you know the j squared is equal to negative 1, where you see j squared, you just know, oh, it's negative 1. Where you see j to the power of, let's say 4, oh, you know it's 1. When you see, let's say, for example, j to the power of 3, oh, you know, oh, j to the power of 3, it will be negative j. Oh, you just have to know it by heart, and then it will actually solve your problems. Okay, next is that you must know when you have complex numbers, you must know the complex conjugate. That means the complex that will actually make another complex not to be a complex, to only be a real number. Let's say, for example, you have 4j, no, let me just say 4 plus 2j. So the conjugate of 4 plus 2j, it will actually be what? 4 minus 2j. So the complex conjugate is actually the thing that gets rid of the j. So this is the real complex, and this is the conjugate of the real complex. So basically, when you multiply the real complex with its conjugate, then your answer will be how much? Let's just check here. You will say 4 multiplied by 4, it will be how much? It will be 16. And then now you say 4 multiplied by what? By negative 2j, that will be negative 8j. And then now you say 2j multiplied by 4, that will be your positive 8j. And then now lastly, you must do what? You must multiply, let's say it's 2j multiplied by negative 2, it will be 4j squared. Okay, remember this is a complex number. You can start with a j on that side or j on the other side. It's actually up to you. So both of the methods are correct. So now you will have what? 16, and then negative 8j with positive 8j will cancel out. It will just be equals to 0. And then now you know, oh, now when I have a j squared, what is j squared? Remember, j squared is always equals to negative 1. That means your j squared is going to be negative 1. Negative 1 multiplied by negative 4. That means your answer will be positive 4, and then your answer will be 20. So basically, the complex conjugate is actually making your complex to only have a real number, or to be one number. Okay, so it actually works when you have fractions. Let me just make an example of a fraction here. If you want to simplify a fraction, but we'll get to fractions. So the conjugate complex is actually more useful when you have fractions. So it actually helps you to simplify a complex with the fractions. Let's say, for example, you have a complex of 2 plus j3 all over 3 plus 5j. You have to simplify these. So basically, when you simplify this, what you can do, you can multiply by what? By the conjugate complex of the denominator here. Because if your denominator is not equals to j, it does not have the j value, it is easy for you to simplify. So what you're going to do, you're going to multiply this number by 1. But this one, it must be a conjugate of what? Of the complex number at the denominator. So basically, remember the conjugate of 3 plus 5j, it will be what? It will be 3 minus 5. Let me j5. Let me just write them like that. Let me start with j5. So also you must also divide by 8 here, because you actually want to multiply this problem by 1 so that you don't change anything. So this is the same as multiplying to whatever this expression is by 1. It will actually remain this expression. But the reason why we are multiplying with the conjugate of the denominator is so that we have let's say how can I put it, just a real number or a whole number in the denominator, so that we can divide by it with the numbers that are it is easier to simplify like that. So now when you solve now, so remember at the top you will be having something like this. That means your first number will multiply with the first and the second, and then the second one will do the same there. So at the top we'll be having 2 multiplied by 3, which is going to be how much? Which is going to be 6, and you say 2 multiplied by negative 5, which is going to be negative 10, and then now you say 3 multiplied 3 j3 multiplied by 3 is going to be positive 9, positive j9, and then lastly you say it's going to be what? It's going to be j squared negative multiplied by negative 5. It's going to be negative j squared 15. And then here at the bottom, remember, let me just give you the shortest way to solve the conjugate here. So you can just say, you can just square the first term here, and you square the last term. Remember, every time when you multiply 3 multiplied by negative 5, it will be negative 15, and then 5 multiplied by 3, it will be positive 15. So always they will cancel out. So what you can do, if you have multiplied the conjugates like this, you can just square the first term to say now the first term is equals to 9. 3 squared is 9, and then you do what? You also square the last term. So now when you square the last term, it's going to be what? It's going to be 5 squared. Yeah? And then when it's 5 squared, I want to show you where the sign that I'll put here comes from. So remember, I already said now, if you say 3 multiplied by negative 5, it will be negative 15j, and then also 5j multiplied by 3, it will be what? Positive 15. So negative 15 and positive 15 will cancel out. But now when you come to this one, it's going to be 5 multiplied by 5, which is going to be negative. Yeah? But remember, it will be negative j squared 25. And then remember, what is j squared? J squared is actually negative 1. So your answer at the end, it will be, so this 9 here is not supposed to be squared, it's going to be 9 plus, because we know j is going to be negative, so it's going to be plus, and then the answer will just be 34. So basically we can conclude to say now, okay, so when you are having we are multiplying conjugates here, you just square the first term to say, okay, it's 3. So you say what? 3 squared is going to be 9. And then secondly, you say 5 squared is going to be what? 25. So you just add them, 25. I don't know why I keep on writing squared here. It's just 9. 3 squared is equals to 9. And then 5 is equals to 25, but you add them, because this j squared will actually get rid of this negative sign and make it positive here, like I've explained. And then the answer will always be 34. Okay, so now we have to talk about the division. I've already explained the division part, but I can just repeat it to make a second example, because I think it's a little bit challenging. Let's say, for example, we have 2 plus 16j. Let me not make a big number because I don't have a calculator with me. So let's say it's 3 plus, let me just put 10, j10 all over, let's say is 4 minus 2j. Okay, so basically this is the fraction that you have and you must simplify it. So the first thing that you will do, you will have to multiply with what? With the conjugate of the denominator. So remember, the conjugate is the same thing as the denominator but with a different sign. So but remember, the number that you multiply with, it must be equals to 1. So that means it's the conjugate of the denominator divided by the same conjugate of the denominator. So it will be what? It will be 4 plus 2 plus j2, and then it's 4 plus j2. Okay, let me just erase and write it nicely here. j2. Okay, so you're just going to apply the very same thing that I've explained. So you multiply this one and that one. You can see I've used a lot of space here, but I can just try to squeeze it here. Is equals to, so it's 3 multiplied by 4. 3 multiplied by 4 is going to be how much? I think it's going to be 12. And then now you say 3 multiplied by j2, that means it's going to be what? It's going to be j6. And then you say 10 multiplied by 4, that is going to be j40. So you will say 10 multiplied by 2, that means it will be j squared 20. I hope it all makes sense. And then at the bottom, remember at the bottom, we can just square the first term. We say, oh, 4 squared is 16. And then lastly, we say plus. It will always be plus when it's you're having a conjugate. You're multiplying conjugates. And then you say 2 squared, that will be 4. So that means the answer that you will have here, it will be how much? At the top, you will have, let's say 12. And then you add 6 plus 40. It's going to be what? It's going to be plus j46. j46. And then this one is going to be what? It's going to be j squared 20. That means it's going to be negative, because we know j squared is actually negative 1. So at the denominator, 16 plus 4, this will give us 20. So now, lastly, that means everything will simplify to what? To say now 12 minus 20. 12 minus 20 is going to be how much? It's going to be negative 8. Negative 8 plus j46. And then we can divide all of it by 20. So when we are here, we can just say, okay, it's going to be negative 8 divided by 20 plus j46 divided by 20. Then you can just put this into your calculator, you get the answer for that. Okay, I hope everything makes sense. I will just follow up with another video that has questions of complex numbers. So this is a scenario whereby you just get an idea what is a complex number and everything. Thank you very much.